Hello everyone and welcome to this section. In this section we're going to see how can we use images of vehicles and no vehicles, or of the road, of trees, or whatever, and actually train a machine learning classifier to classify a camera image into a vehicle or no vehicle. It can actually detect where the vehicle is located within our image and actually draw kind of a boundary line around it. Okay, so the first step is we're going to apply hog features, which is histogram of oriented gradients, to actually extract the features out of the image. And then the next step is we're going to apply support vector machines classifier to actually train a classifier using different images of vehicles, of no vehicles. And afterwards, we're going to combine all that information to actually test it simply and test the trained machine learning classifier to actually classify newer images that the technique hasn't seen before during training. All right, it's pretty interesting, pretty exciting. Let's take a look. So first of all, let's take a look at kind of like the data. So guys, the data you guys can see here in the vehicle image database, kind of different images of vehicles of different size, different sides. You can see image kind of like close, a little bit closer, a little bit further, a little bit from the right, a little bit from the left, a little bit from the right, and so on. This is kind of a list of images. And what we're going to do, we're going to take all these images, extract the hog features or histogram of oriented gradients, all right? Take all this data, train a machine learning classifier, a support vector machine, to actually know, okay, when I see these features in a car, that means a car, okay? So I'm sorry, when I see these images in a camera image, for instance, this region or this area indicates a vehicle, indicates a car, okay? So I can just raise a flag that says, okay, well, car detected. That's pretty much the whole idea of the strategy. That's one database. And another database, it has several images as well in here, okay? And you guys can get as well to that GitHub. You can download the images in here just for the training data and for the testing data as well, all right? All right, let's run it. So that's first step. So we just import all the libraries. Next step is here, we're just gonna import the images of car and no car, we called it. Length of car, we're gonna tell me how many images I have. So I have 8,792 images. And then if I obtain the length of the car, that will tell me, length of no car, that will tell me how many samples do I have for the no car images. I have 8,968 images, okay? The next step is I'm gonna take a sample of an image. So this is basically, I was just gonna went inside the car array. I was just gonna grab, let's say, sample number 20. Shows us like, kind of an image. Let's try, for example, 200. Let's run it. That's okay, that's another image of a car. Let's try maybe 300, maybe another image of a car, and so on and so forth. Okay, and that's kind of all the image you're gonna be using, 8,000 images. Just gonna take them, train a classifier with them just to detect the features of a car. All right, we're gonna take an image, we're gonna shift it or change it to grayscale. That's what we're gonna did here. We're just gonna use cv2.color BGR to gray to convert an image to grayscale. And then what we're gonna do, we're gonna obtain hog features. Again, you guys are experts by now when it comes to hog features. We're gonna, again, use image gray. I'm gonna apply orientations of 11, so 11 orientations, 11 angles. You guys remember? I'm gonna use 16 by 16 window for the cell window. I'm gonna use 2 by 2 cells per block. And then I'm gonna plot this. All right, so here I'm gonna show the hog image, the shape, and then I'm gonna show the features of the hog image, which is, one of the values I'm gonna get out of when I apply hog, which is a hog image, okay? That's pretty interesting. That's pretty much the image of a vehicle. So a car, when the computer basically sees a car as this, just a bunch of stars that indicates, gradients, direction, and gradient magnitudes. All right, looks great. Let's keep moving forward. So what I'm gonna do here, I'm gonna take all these images. Okay, what I'm gonna do, I'm gonna obtain the hog features for all these images. Okay, that's the first step. All right, so let's see how can we do this. So first of all, we're gonna create a for loop for I in car. So I'm gonna take all the car images, I'm gonna loop in them. Every time I'm gonna read the image, okay, I'm gonna apply exact same stuff that we have done before on a sample image. I'm gonna do it for all the data. We're gonna obtain the grayscale image. and then I'm gonna apply the hog feature. Okay, that's pretty much it. And then afterwards, every time I'm gonna get the card hog feature, which is the features, we're gonna just append it to kind of, you know, like card hog accumulator, which is an accumulator that accumulates all the features for all the images. And once I obtain this, that basically just, you know, an array that represents all the hog features for all the images that I had so far. Okay, all right, let's run it. And it's taking a little bit of a while because, you know, as we have 8,000 images, so we're doing this like almost 8,000 times. So again, by the end of this section, we're gonna come up with card hog accumulator, which is, you know, an accumulator that has all the hog features in here. Okay. Okay, until it runs, let's keep going. Let's move forward and see what we're gonna do with it. Next step is we're gonna create simply our training data. What I need is that I need to have, again, as you guys remember, to train any machine learning classifier, I need to have features, okay? And I need to have kind of label. So I'm saying, okay, when you see these features, when you see these hog features of cars, raise a flag, which is, you know, my label, the output of the network, will gonna be 1, which indicates, oh, car detected, simply. If I show you all these images, okay, of no cars, then indicates 0, 0, which indicates, okay, no car has been detected. That's in a nutshell, okay? So what I'm gonna do here, we're gonna simply create the card hog accumulator. We're gonna simply create numpy.vstack, or the vertical stack, just to stack them in a way to generate xcar, which is, you know, the vector or the array that has all the features in it. And then here we're gonna create simply the y, which is our label, we're gonna be 1s, just creating 1s of the length of car. Okay, now we're done. Let's run this and let's take a look at xcar. So simply now I have 8,792, which makes sense because I have 8,792 images of cars, and for each one I have 396 features, which is simply, that's the hog feature per image. Okay, and that's, if you recall here, when I did just hog feature for one image, I obtained 396. Okay, and that's pretty much what I got here too. So 396. Okay, all right. Let's take a look at Y car. That's Y car. I have 8,792 values, and all of them should be 1. Actually, let's view it. Let's take a look at it. So that's my Y car. Let's run it, and it makes sense. All of them are 1s, indicating, okay, when you see these features, raise the output of the label, we're going to be 1. All right. Let's do the exact same thing, but for no car. So what I'm going to do here, again, we're going to create a loop for I in no car. Every time we're gonna create, grab an image, and then we're gonna create grayscale image, and then we're gonna do a hog feature again, and then we're gonna append it to our accumulator, and then afterwards we're gonna create an X of no car, which is simply our features, and then our target class. And just the most important point here we specify np.zeros, which means I'm gonna create an array of zeros because it indicates there is no car has been detected. All right. Okay, let's run it. It's taking a little bit of a while. And here afterwards, we're gonna create again X no car, Y no car. We're gonna show all of them. And now we're pretty much ready to simply combine the features of a car, features of no car, labels of car, which is 1, labels of no car, which is 0, mix them together to come up with, you know, all the training data, and that we can use to train a classifier or support vector machine classifier to actually detect features within the image. All right. Again, it's taking a little bit of a while to just extract features using hog features out of 8,000 images of no cars. But again, that's pretty much all what we have so far. All right. Afterwards, after we do this, we're going to come up with an X and Y values. Afterwards, we're going to train a support vector machine classifier to classify simply this. Again, afterwards, make it better. We're going to improve the model. We're going to try to tune the C and gamma parameters, and then we're going to test our algorithm afterwards. And that's pretty much, we're going to summarize all what we need in this section. All right. Again, it's loading. You guys obviously can try to try different orientations, for example. So here, if you can try more orientations, 11 or 9. You can try maybe less orientations, and again, you can try different pixels per cell, and and so on. Okay, now we're done. We're gonna go down here, we're gonna run it. We're gonna run it one more time, which makes sense. That's why, that's X with no car. So I have again 396 features, and I have 8,968 images, which makes sense. Okay, now I have Y no car. Now I create basically, again, an X, which has all the images of cars, no cars, all the features of X and X cars and X no cars, along with the labels for Y car and Y no car. Let's run it. Let's run it one more time. And that's pretty much what we have so far, which is, I have 17,000 samples. Okay, and each sample has 396 basically kind of a feature vector that indicates the hog feature of this image. All right, sounds great. Let's keep going. So first we're going to train a support vector machine model classifier. So in order to do that, we're going to import from sklearn.model selection. We're going to import train test split. Again, we're going to divide the data into training and testing. So here we're going to use train test split. We're going to pass along the argument X and argument Y, which is my data. I'm going to extract 25% to be used for testing, and 75% we're going to be used for training. All right, and simply that will return X train, X test, Y train, Y test. Okay, let's run it. All right, and then the next step is what we're going to do here is that we're going to import a linear support vector machine classifier, or linear support vector classifier, linear SVC. All right, and we're going to import what we call a classification report and confusion matrix. I'm going to show you what does that mean later on. And what we're going to do here, we're going to instantiate an object from the linear SVC. And that's going to be my object, okay, SVC underscore model. And then we're going to use a method, fit method, on my object using my training data, X train and Y train, to actually train or fit my model with that data. Okay. All right, that's it. Actually, the model has been trained, which is fascinating. Now I have a trained model, which is SVC underscore model. That's simply a trained model, which looks, like works great. Then what I could do is that I could use that trained model, SVC underscore model. I can use the method predict on my model, and then I can pass along data that the model hasn't seen before during training. And that's why I passed along X test simply to predict or to provide Y prediction, okay? And then afterwards, what I'm going to do here, I'm going to plot what we call the confusion matrix. Confusion matrix, I'm going to show you what it is. It's just a simple kind of a one-stop shop that shows you all the information of the correctly classified samples and misclassified samples, okay? So we're going to use confusion matrix. We're going to pass along Y test, okay, and Y predict, and that will return back CM. And then I'm going to use the Seaborn library, sns.heatmap, to simply plot my confusion matrix just in a beautiful way, in a kind of an interesting way. Let's run it, and that's pretty much it. So if you guys can see here we have again two classes, and that's the confusion matrix. So what we have here on the rows, that's my my predictions. That's what the model predicted. Here I have my true values. Okay, so if my predictions matches my true target values, then the number of samples that have been correctly classified will be here. Simply put, the model said I'm 0, okay, which means there is no car detected, and actually there was no car detected in the training data as well, or the testing data. So that means there is 2,000 samples that are pretty good, okay? Here, the model said that there is a car detected, which is 1. However, there's actually a car that's detected already, which is a true target value is also 1. And that's why you come up with around 2,000 samples that are correctly classified as cars. However, now to the trouble. These are kind of the troubles. These are kind of, the samples that are misclassified, which is, we know what we love to have, them 0, basically, if we can. All right, let's run it one more time. And that will provide us with kind of, summary of classification reports. So now we reach around 95% precision, which is not bad. And then afterwards, what we're going to do here, just kind of, run a sample. Just going to go here, X test. I'm just going to take, let's say a couple of samples and compare the prediction with the true label, with the true value, to see if that makes sense or not. Let's run it. And that's kind of, what the model is saying. What the model is telling me that, the first picture is 0, no car. No car, no car, no car, car, and so on and so forth. We're going to do the exact same thing for the first 50 samples, and that's the model prediction versus the true label. if you guys can see here, okay, it looks good up until this point. Here there's a mess up. Here the model messed up. Here we're good, we're good, we're good, good. All that is good, 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 good. It's actually not bad. And then here, that's for the first 50 samples of the data. If we keep going, we're going great. All of them pretty much are, here there's a mess up here, there's 1, here it's showing 0. And that's pretty much how can you, kind of tell if the model learned or not. But again, instead of plotting this data all over and you try to compare them together, just use confusion matrix to tell you, okay, how many samples that are correctly classified and how many samples that are misclassified. All right, okay. All right, the next section we're gonna be discussing is how can we improve the model? How can we make it better? So what we're gonna do here, if you guys recall the C and gamma parameter, what we're gonna do is try to optimize the C and gamma parameter using what we call it parameter grid, okay? All right, let's take a look. So what we're gonna do here, we're gonna create a grid or param grid equals to, here are all the assumptions, all the values for the C parameters. Here are all the assumptions for the gamma parameters. And here we're actually gonna use an RBF or radial basis function instead of a linear classifier, okay? And then we're gonna import from sklearn.model selection, we're gonna create the grid search CV, which is very simply, we're just gonna create kind of a grid, okay? And try all the samples, all the numbers of, I provided here, 0.1, 1, 10, 100, and all the gamma parameters that I provided as well, 1.1, 0.01. It's kind of, trying to look for, okay, which C and gamma parameter will provide the best value, okay? All right. And then what we're gonna do here, I'm gonna run a grid search, all right? So grid search CV, that will simply, I'm gonna pass along the SVC and then parameter grid. And then afterwards, we're gonna apply the fit method on the grid using the X training data and Y training data. And afterwards, I'm gonna use the best params method and the best estimator to give me, okay, what are the best C and gamma parameters that I can do. Again, instead of writing codes and for loops and stuff, that we're just gonna do it for us. And then simply grid best parameters, that would be the best values that we could use to train our classifier. All right, so let's run it. So as you guys can see here, we're just running the algorithm just to try to look for the best C and gamma parameters for us. Again, it's just gonna take a little bit of time, so just gonna fast forward into it and come back to you guys very soon, okay?